Okay, so let's do some trig limits. So the first one we're just going to be looking at is probably the most common one you'll see. The limit as x approaches 0 in the function sine x over x is going to be 1. Now there's a lot of ways to prove this, but the most easiest way to just visualize it is by showing the graph. So this is the graph of sine x over x, and it basically oscillates between y equals 0 infinitely many times. But as it gets closer to 0, it's going to approach 0 and continue oscillating. And right here, this is just the point 0, 1. And we're going to be using this, I guess, identity, if you want to say, to solve some trig limits. Okay, so let's solve this first limit we have. So we have limit as x approaches 0 in the function sine 5x over 4x. So we have to figure out a way to isolate or manipulate this function so we can end up with what we had before, sine x over x. So what we can do here is multiply the top and bottom by 5 over 5. Because at the end we're trying to get the angle in the numerator to be the same as the denominator. So I'll show you what that looks like. So we can just swap the 4 and 5 here. So we can just say this is limit x approaches 0 and the function sine 5x over, and if we just swap these, we can just say 5x, and then now we have 5 over 4. So this looks similar to what we had before, sine x over x, but this time there's 5. But it doesn't matter as long as it's the same. So here it's 5x and here it's 5x, so it's gonna be the same. So we can just say this equals 1, and this is just 5 over 4. So the limit of a constant, or the limit as x approaches anything for a constant, is just going to be the constant. So the final answer is just 5 over 4. Okay, so next one, we have, again, limit as x approaches 0, but this time in 7 sine x over 4x. So we can use the same strategy. What we want to do is get 7x in the denominator. So what we're going to do is multiply 7x on the top and bottom. And again, we can do this because all 7x over 7x is just 1. Actually, we don't need the x. We can just leave it at 7. So 7 over 7 is just 1. So you're not changing the actual function at all. So what this is we can change the 4 and 7. So sine 7x over 7x times 7 over 4. And now we have the angle in the numerator is the same as the denominator. So this can just be replaced with 1, and this is just 7 over 4. And again, the limit as x approaches anything for a constant is just the constant itself. So the answer is just 7 over 4. Okay, so number 3, we have limit as x approaches 0 in the function 1 minus cosine x over x. So this is another really common trig limit that you'll see when doing these types of problems. So the first thing I would do is I see that this is 1 minus cosine x in the numerator. So what I'm going to do is I'm going to multiply the top and bottom by 1 plus cosine x. And the denominator 2. And now if we multiply the numerator, we'll have 1. And then 1 plus cosine x, or 1 times cosine x is just, and 1 minus cosine x is just negative cosine x. And then negative cosine x times cosine x is negative cosine squared x. And so we can cancel these off. And the denominator, we don't necessarily have to multiply, so we can just keep it as x times 1 plus cosine x. And now if we simplify this, we'll have 1 minus cosine squared x over x times 1 plus cosine x. And this might look a little familiar too. So if we go over here, we know that the Pythagorean identity sine squared x plus cosine squared x equals 1. So if we rearrange this and subtract cosine squared x from both sides, we'll end up with sine squared x equals 1 minus cosine squared x. So we can just replace 1 minus cosine squared x with just sine squared x. So if we go over here, we have sine squared x over x times 1 plus cosine x and now we have sine squared x over x times 1 plus cosine x. So here there's really two sine x's. So this is really just sine x times sine x. And this right here is really just x times 1 plus cosine x. So we're going to split this apart. So we're going to have sine x over x times sine x over 1 plus cosine x. And the reason I did that is because I wanted to split apart so I can get sine x over x, which is, we all know, is just 1. So this is just going to be 1. So sine 0 over 1 plus cosine 0. So this is going to be 0, and the denominator, 1 plus cosine 0, and cosine 0 is 1. So 1 plus 1 is 2. So when 0 is in the numerator divided by a constant, or something that's not 0, the answer is always going to be 0. So we can just say the limit as x approaches 0 in 1 minus cosine x over x equals 0. Okay, question 4, we have the limit as x approaches 0 from the right in the function sine x over square root x. The reason why they're asking 0 from the right is because there's no graph or there's no value for this function when x is negative, because as you can see here, there's a square root, and whenever you have a square root, x has to be positive, because anything that you square root that's negative is going to be an imaginary number. Like if this was negative 4, the answer would be 2i, but that's not a real number. It's imaginary. So that's why it's from the right. So we're only going to see the limit as x approaches 0 from the right. So let's do the same thing that we always did before. So we multiply the top and bottom by whatever the angle is. So what we're going to do is try to get square root x to be x. And the only thing to do there is to multiply by itself, square root x. So let's multiply the numerator and the denominator by square root x. So now this is going to be sine x over, now we can multiply this. We don't have to switch anything. We can just say we can multiply them and say this is x, but we still have the numerator, which is square root x. And we know this is just going to be 1. And square root x, when you plug in x is 0 in square root x, this is just going to be 0. Because 0 times 0 is obviously just 0. So the function, or the limit as x approaches 0 from the right in the function sine x over square root x is going to be 0. Okay, so next one we have is something different. The limit as x approaches pi over 2 in the function cosine x over cotangent x. So the first thing we'll do is let's rearrange so we don't have cotangent in the denominator. So this is really cosine x over 1 times 1 over cotangent x. And we know cotangent x is the reciprocal of tangent x. So if we take the reciprocal of it again, we're just going to get tangent x again. So we can just say cosine x, this is just cosine x, times tan x. And tan x is really sine over cosine. So let's rearrange that again. Cosine x times sine x over cosine x. And now we have, in the numerator we have cosine x, and the denominator we have sine x. So we can just cancel these off. And now we're left with limit as x approaches pi over 2 and the function sine x. So you see how this entire thing just simplified down to sine x? It's just because the only thing you really need to figure out was that the reciprocal of cotangent x was tan x. So now if we plug pi over 2 as the angle, sine pi over 2 on the unit circle, that is going to be 1. Okay, so question 6, we have the limit as x approaches 0 in the function sine x, 7x squared over 1 minus cosine x. So again, we have 1 minus cosine x in the denominator. So what I want to do is multiply the numerator and the denominator by 1 plus cosine x. And now, let's just multiply the denominator first. So we'll keep the numerator the same. So 7x squared times 1 plus cosine x. So we're not going to do anything with that. And the denominator, this is just going to simplify down to 1 minus cosine squared x. And now, let's rearrange this a bit. So this is going to be the same as 7 times x times 1 plus cosine x, all divided by, and we know this from the Pythagorean identity is sine squared x. So this is also really just sine x times sine x. So what we're going to do is split apart so that x is in the numerator of the sine function. So let's say this is equal to x over sine x times x over sine x. And see, I'm not changing the function at all. I'm just rearranging it so we can isolate the sine x. And then now we can just multiply 7 times 1 plus cosine x. Okay, now this looks a little familiar. X over sine x. Usually we've seen it as sine x over x, where this is in the numerator, but it won't matter at all. Even if it's a reciprocal, the identity still remains the same. So x over sine x is going to equal, or when, I guess, after we plug in 0, this is going to be 1. This is also going to be 1. So now we have 7 times 1 plus cosine 0. Cosine 0 is just 1. So 7 times 2 equals 14. And that's the final answer.